Okay. Good afternoon. Thank you for joining us for the second part of the Young Academy of Europe's Arts and Science webinar series. My name is Serim İlday, and I am the Activities Chair of the Young Academy of Europe. I'll be moderating this event. Complex scientific ideas and concepts can be made more accessible, engaging through artistic representations, visualizations, animations, and interactive exhibits. Bridge the gap between the abstract and the tangible, enabling the public to grasp intricate scientific phenomena and foster a sense of wonder and curiosity. So with this in mind, we have invited two world-renowned experts and excellent speakers on data visualization and communication. Albert-László Barabási, an eminent network scientist from Northeastern University, Harvard University, and Central European Universities, and Felicfabric, an award-winning science photographer from MIT. They are both authors of multiple best-selling books and have had several artistic exhibitions in prestigious art galleries showing the beauty of their work. We will record the event except for Felic's a few slides and share it later on our YouTube channel. After each talk and at the end of the event, we will have the time for questions and discussions. So let's start with László and see the hidden patterns, the visual journey of networks. So László, the screen is yours.
Thank you, Sarim. So let me do the technology of sharing my screen. So bear with me for a moment, and then we can start the conversation. So I'm assuming you can hear me in the meantime. So it's a pleasure to be here and to be part of this conversation about art and science. And here we go. And I guess I did not remember my other title, so I created a new one, but let's kind of get started of why am I here and what's kind of the connection between art and science in my lab. So I'm a network scientist, which means that I spend much of my time studying networks like what you see over here, which is really the protein interaction within our cells, that how each protein interacts with others. But I also focus a lot on brain networks, what you see over here, which is kind of capturing, how the neurons are connected between the brain, and ultimately, the hope is to understand through that brain function and consciousness. And also in my lab, there is a very active line of work focusing on science of science. That is, what can we understand about the pursuit of science through data and mapping out the connections between people, between ideas, between institutions, and quantifying effectively our way of doing science. And I'll come back and talk about some aspects of this. But the question would come is that, why am I interested in this intersection between art and science? And one reason I am very interested is because before I became a scientist, or before I decided that even science is interesting for me, I was studying to become an artist. I was hoping to become a sculptor, to be more precise. And what you see actually from the 1980s, some of the sculptures that survive from that era that I've done as a student. But this was happening in Transylvania, Romania, under the Ceausescu's communism. And soon after I was pursuing the drawing classes and sculpting classes and do everything what requires for you to kind of build a career in art, I realized that there is no path forward because there were only 5 spots in sculptures in the country. So it was virtually impossible to get admitted at that time during communism into an arts university. So I ended up choosing the easy way out and became a nuclear physicist. Now, what happened, of course, in the meantime is that from nuclear physics, I switched to theoretical physics. And eventually, kind of 10 years after these sculptures were done, I joined IBM. And it was there at IBM when I suddenly became interested in networks. So this was 1994, December. I remember exactly the date, living in the New York City and kind of imagining the many networks around me. And it was that moment during the Christmas that I said, okay, my next pursuit will really focus on large, complex networks, understanding their structure. And interestingly, the very first product of the journey was not a research paper, but was a visualization. And what you see here on the right-hand side, this particular picture is very accurately dated because we still have actually the transparency, if you remember what that was, that has a date that the computer automatically put on it as 1995, January 17, which means that really 3 weeks after I became interested in networks, I started to explore them using the computer and visualize them. Eventually, this was published 2 years later, kind of in 1996, or a year later after the image was created. And in a way, this kind of marks the beginning of my own journey of what I would call scientific visualization. And of course, this journey has taken me to places that I could have not imagined back in 1996. And to kind of have an idea, here's the same image in a different setting in the museum, in the Ludwig Museum, in a totally different scale and kind of in a totally different context. So what I decided that I will do today in the short time kind of available for this part of the lecture is to tell you 3 stories of how science and kind of art and visualization are intertwined in my lab. And I will, for that purpose, I will pick 3 projects. Some of them are relatively research projects to understand why do we do visualization and how the visualization and the art is an integral part of the scientific journey. And I would like to start with physical networks. Physical networks is an area of research that is very active currently in my lab. And by physical networks, we mean networks where the links themselves are physical objects, like the neurons in the brain, that it's a physical cable of the neuron, and they cannot cross each other. They can go by each other, but they cannot cross each other. And only recently, say about 5 to 7 years ago, that we started to have accurate maps, for example, of the brain, and this is what you see in this particular image. It's an artificially colored kind of version of the fruit fly's brain. What we colored is that we gave different colors to the individual neurons. And I did so just to illustrate the exceptional resolution now we have about physical networks in some context. So I was very, very interested in physical networks for many years. And only about 4 or 5 years ago, we actually started to develop algorithms to how do you lay out a physical network, where the challenge is that in contrast with the traditional network layout algorithms that some of you may have used as you visualize some simple networks, here the links are not allowed to cross each other. We have a whole history of network visualization going back to the 1990s and different algorithms. But in all of those algorithms, we assume that the links are not physical entities, so they can easily cross each other. Nodes can cross each other. They are not visible to each other. So how do you model physical networks? Well, many of you are scientists. This is my language to talk about physical networks, right? Which is actually writing up a formula that will tell me what is the energy of a physical network. And within this formulation, we penalize with energy, with very high energy, every time 2 links want to cross each other or a node wants to cross a link. So this is one way a physicist would actually describe that the links are not allowed to cross. What do these formulas do? It allows us to start with a random layout of an arbitrary network and then effectively find the optimal layout, where optimal in this case means minimizing the total length and yet still laying out the network. And what this formula achieves, in contrast, as I said, there are lots of network layout algorithms, but they would do what you see on the left-hand side, that the links could easily cross each other that you see in the middle, because the links and the nodes are not visible to each other than the distance between them. However, the formula that you saw in the previous slide would take these nodes and instead do that, which you see that the nodes and the links are now carefully avoid each other. Now, this is just an algorithm that kind of allows us to lay out larger networks. And back then, when we produced that, which was in kind of 2018, we wanted to test it in a larger network, not just a toy network. And for that, we ended up choosing a network that we mapped out a decade earlier in 2011, which is what we call the flavor network. Flavor network is fun of its own because the nodes correspond to the different ingredients that we use in cooking or in producing food, like onion and garlic and vegetable oil and olive oil and cumin and ginger and you name it. And two ingredients are connected if they carry the same flavor chemicals. That is, the chemicals that are responsible for their flavor. Why did we map this network out back then? We mapped it out because there was a hypothesis in molecular cuisine that ingredients taste well together if they share flavor chemicals. So molecular cuisine imagines that cooking is a little bit like, kind of putting together the plan of an interior plan of a house or dressing up, that you use the same colors over and over in a touch of colors over and over to kind of create a harmony. And the same way our palate perceives a harmony if the different ingredients share some of the flavor chemicals. And to test that, we ended up building this network. And of course, we got the answer whether really food tastes well together if they share chemicals or not. But the topic of the talk today is not that. Then we took this network and we ended up using the algorithms that I showed you earlier to lay it out in three-dimensional space. And this is kind of what you see now on the left-hand side, the algorithm in action. It starts with a random configuration, and it's kind of optimizing the layout to minimize the link length. And eventually will converge to kind of what we call often a fixed point where it cannot really improve any longer on the layout. And what you see is that clear communities have emerged along these. These correspond to actually groups of foods that are very similar in their chemical composition, like fruits, like different type of meats or different type of drinks, that then they actually work together. To see the better, actually, I'm showing you here how this is actually was shown at ZKM Museum in Germany as a sculpture, because once we had the layout, we could go ahead and 3D print this particular sculpture. Now, once you treat, now one of the questions is, why do you want to first of all lay it out in 3 dimensions versus looking at 2D, the map that you showed? Well, one of the reasons we want to lay out in 3 dimensions is because in 2 dimensions, all networks have, all links must cross each other actually. So in a sense that you cannot lay out without link crossing, but there are mathematical theorems to tell us that in 3 dimensions, any network can be laid out without links crossing. But most important, this was my personal journey to take network visualization out of a 2-dimensional space and create a sculpture. Remember, I wanted to be a sculptor before I became a scientist. Now, every time you do this transition, the sculpture itself stops carrying some of the information, because on the map, you can label things. In the sculpture, you cannot. So for that reason, we ended up actually creating an app that if you are watching through the app, the sculpture, the information will be given back to you, and you can play with it and see which ingredient is what. And in a way, the information can be gained back. But fundamentally, the information is now embedded in the network. Now, why did we do all of this? Well, because there, as I said, there was a very interesting scientific question that we were exploring that was eventually published in Nature, that to what degree the physicality of the network affects its layout. And particularly, we asked the question, and this is shown on the plots on the right-hand side, that if I'm increasing the thickness of the links, would it force the network to lay out in a different way? And the answer is yes. We ended up discovering that there are 2 very different phases in the way the network wants to lay itself out. And to see what different phases are, that it's kind of originally most network visualizations are like this with very thin links, but now I'm making the links thicker and thicker. And when I do so, there's not enough space for the links to reach their destination through a straight line. So they're forced to curve and create this very dense object that we name Gurka, from the word gorge, actually the Latin version of gorge, which is kind of like, like things are trying to burst out because there's not enough space to flow freely. Now, part of the lab's journey is really, interestingly, is to take some of these objects that come out in the scientific discourse and put it in a different context. And in a different context means find materials and find representations that are mostly coming from the art space to really show this in a different environment. And I'm going to show you that, for example, hold on, just that, like how this actually object now looked first shown in a museum on the left-hand side, which was kind of turned in this case into a ceramic at Pécs near the Zsolnai factory. But I continued this journey searching for the material, what really best represents that Gurka object. And this is one of my favorites. So this is obviously made, it's got out of marble. But the reason why this is so special to me is because the professor who taught me sculpture back when I was in high school, when I was preparing to go to art school, has agreed to actually carve this out of marble. So, and this is kind of a memento of him. This actually was finished 2 years ago. And since then, sadly, he passed away. And then, of course, we also tried different entities. So this is a version where we kind of created the same idea out of inflatable tubes, right? In a very, very rainy day, actually in the museum courtyard in Csíkszereda or Mekureachuk. And the latest version of this journey is actually shown right now in Romania. And what you see here actually is that we try to see how would that work in the wood. Why are we trying all of that? Because I'm trying to experiment what is the material that best carries the message. And this is a series that we've been continuing in the case of Gurka to try different material types. Now, as a final journey, I would like to tell you about some more recent work. But actually, no, these were contemporary. This happened roughly at the same time that led to this particular visualization. The story of this is actually very interesting. Around 2018, I believe I got a phone call from the editor-in-chief of Nature telling me that they are preparing to celebrate the 150-year anniversary of the journal. And they were wondering if I would be interested helping them design the cover for the anniversary issue. And this is kind of my first quote-unquote commission that I ever got, right? All the other works we did out of our curiosity within the lab and not because we had an external kind of request. And so, but obviously this opportunity comes once every 150 years, so we agreed to that. And what did we end up doing? We ended up mapping out the 80,000 or so papers that Nature has published during his 150-year history. And each of these papers is presented as a little node or a sphere in this particular image. And the different colors correspond to different disciplines. For example, yellow is biology in this case, and green is physics. The question is, when do we connect them? And the natural way would be to connect them if they cite each other. But you have to be aware of that citation is a new thing, really. It's kind of really citation took habit in science since the 1960s. Once the refereeing became of mode and the referees started to actually push the authors to start referring to others people's work. Before that, it was very rare to refer to earlier papers and to give explicit references. So if you use citations, much of the early literature would be lost. So we ended up using co-citations. We ended up connecting two papers if they're connected in the community's mind, meaning that today we cite them together. And obviously, often biology papers end up citing more often together, and physics papers end up citing together. But often there are papers that cite both the biology and the physics paper, and hence there are links between different disciplines. So in many ways, this particular image kind of captures many, many different things about science. First, its multidisciplinary nature. how the different disciplines coexist within one big scientific enterprise, but also the deep connections within each field as well as across different fields, right? So it captures somehow the unity of the science that is not just an isolated set of fields, but we're all connected. In our mind, there are connections between many different, often disparate discoveries. Now, the product of this journey was obviously this image that ended up on the cover. And instead of having a one cover, we ended up having at the end a 5-page cover because, you know, that the way it laid out, it was also in the back material and so on. It was also a video that's available online if you search for Nature 150 that tells the story of nature through this particular visualization. And this way you can see that that's not a 2-dimensional image. This is really a 3-dimensional laid out kind of data sculpture that you just saw one particular reflection. And of course, this particular work also now has kind of existence in other mediums. You know, and we'll show in a second. The only thing that I'm said about this video, if you find this on the web, you will see that actually there is a narrator that tells the story, and that narrator was supposed to be Attenborough, who agreed to actually narrate this video for the 150-year anniversary for Nature. And when the video was done and the text was written, then Nature was desperately trying to get in touch with them to do the narration, and sadly he did not respond. They ended up finally doing the narration with someone else, just to learn later that he would have been happy to do it, except that he does not read email, and hence he never saw the request to actually come and do the narration. Right? But anyway, it's very well done narration-wise. And finally, you know, this is how, for example, this work is now being shown in the museum context as a work of its own, kind of presenting the unity of science. This one was in Milano that just closed this spring. And this is a good moment for me to end this thing. If you're interested in the lab's journey in art, we do have a beautiful catalog kind of published by Hudson Kuntz that kind of shows the history of 25 years of network visualization in my lab. And of course, I have also written extensively about some of this journey, most recently in the formula that I kind of explore the interplay between artistic as well as scientific success, the similarities and the differences between them. And I will just end to say it always takes a village. So I had many, many lab members who have contributed and designers to all of this beautiful work that you have seen. And we will not get to the end of it. But thank you very much for the attention. And I'm looking forward to the conversation.
Fantastic visual journey. Thank you, László.
Thank you.
So we have 33 attendees at the moment, and we already have a question. Abdullah, can you unmute yourself and ask?
Thank you, Professor Barabási. It was an amazing talk. I've always wondered while studying quantum mechanics, like, is there a very good way to visualize some quantum connections, like entanglement and superposition? I mean, it's very confusing for students usually to actually visualize it in their mind. So I was wondering, because there are many different levels as well, right? You can entangle two particles, you can entangle multiple degrees of freedom, and then there are different strengths of entanglement. So I was just wondering, do you have a preference in your mind maybe of how these things should be represented?
So it's a very good point. And entanglement is really a probability field, right? So one would actually have to play with the idea of the probabilities and how you kind of find a way to show that probability turns into reality in some context. I don't have a good way to do that on top of my hand. And I do want to emphasize that each of these visualizations you have seen, they were the results of thinking about the problem anywhere from 6 months to a year. So, and we develop typically multiple metaphors for most problems. And then one actually ends up winning that is being shown, like in this case for the Nature 150. And we had actually situations, we had 4 very different narratives. And then of course, one was shown and the others were kind of discarded. So every visualization, at least in my mind, is a storytelling. So how you show, in this case, the entanglement and the probability field would really be determined what is the story that you are telling, what is we are trying to convey. So it very much depends on the context of what's your narrative.
All right. I guess then everyone can think about it and maybe have their own visualization.
Yeah.
Okay. Thank you.
I call it artistic freedom.
Kathleen?
So congratulations and thanks again for this talk. I would have rather a kind of practical type of question. So how easy it is to convince galleries, but before convincing galleries to convince artists to collaborate with you? I know your old teacher, it was probably a personal story, but otherwise, can you give some advice on that? Or maybe with your name and your connections, it's much easier, but could you tell some practical advice on this?
So first of all, I must say that most of these images that you have seen were developed in the context that we never thought that they would ever be shown in a museum or gallery. They were part of our personal journey. And the reason why I ended up doing from day one network visualization and even hire designers in my team and artists in my team regularly. Mauro Martino was the very first designer about 50 years ago. And since then, we always have at least 1 or 2 people on staff, is because I consider visualization as part of understanding the systems we explore. And the journey that we're showing this is very, very recent, that we kind of show it outside of the scientific context. And it was about 5 years ago when first these images were actually requested by a curator whose name is Hans-Ulrich Orbist, and he showed it at Serpentine Gallery. And then eventually kind of the real time when everything got shown together was when Ludwig Museum offered us an opportunity to do a retrospective. In none of the cases, I did the convincing. They found us and they showed us that thing. What has happened since then, however, since 2000, is that we have changed our way of operating, and we do have actually lots of works that we create specifically with the aim of being shown in the gallery or the museum setting, but they're all rooted in the science that is being done in the lab. So what you need to kind of, hopefully it was clear that every single work that we have done is based on the lab's journey. So the data is being cleaned and understood by the research part of the lab, and then eventually passed on to the design team, or through me actually. And I say, okay, now I think this project is interesting enough and ripe enough to do something more than simply doing the math. So we have the luxury of having a team to clean the data and build the narrative before we actually start the visual journey. But often the visual journey is also helping us the narrative, and they go hand to hand in that sense.
Okay, thank you very much.
If you have another really short question, we can take it. Otherwise, we will switch to our second speaker. Let's do that. Now, Felice will show us more than pretty pictures. Felice, the screen is yours.
Okay. Hi, it's a great pleasure to be here. And Laszlo, I'm so excited to talk to you offline. We've got a lot to talk about. Your work, of course, is extraordinary, but you're raising some issues that I think about all the time. So I'm going to try to make a case that making representations, which is what we're talking about, is making more than pretty pictures. I will tell you offhand, real fast, I'm not an artist. I design images and graphics to communicate. So I have to make that distinction. I'm interested in more using the word design, because for me, it's ultimately about communication. I believe that making these representations should be part of your thinking from the very beginning of your research, and frankly, even before. First of all, I would like to suggest that making a representation that's highly communicative brings attention to your research. Here's an example of Alice's picture that she made, a photograph of her material that she is actually studying insulation. And this is the material she fabricated. It's fine. But this is what I do on campus. I have this incredible luxury. I took the material, and this is the picture that I made. It is, I think, I hope you agree, more engaging, maybe clearer perhaps. For those of you who want to know how I made it, I'm happy to, you can write to me. It was basically stacking images to get everything in focus. But the point is that I helped bring attention to the work with making an honest picture of the same material. Making the right kind of visual helps communicating the science. This is obvious. But the problem is we talk too much to each other, and we just assume that it's communicating to each other and to other people. This is an image that I still show. It's not mine. This is how I started this whole new world in science. I have a background in science, but I initially became an architectural photographer. It's a long conversation. I came back to science because I invited myself to George Whiteside's lab, and this is the image that they made of their material that shows self-assembled monolayers. Basically, what you're looking at is hydrophobic and hydrophilic areas creating lithographically. This was out of 90, I think it was 92. This is the picture that they made. This is how it was used in the journal. And I said, let's do something a little more communicative. This is pretty old, but I still show it because I maintain it is a good example of how good quality images can communicate better the science. Basically, I asked them to give me another sample. Can I color the water as I drop it on the surface? It basically, the water stops at the hydrophobic line. And I believe that my picture not only is maybe more attractive, and that's perhaps one of the reasons why it made the cover of Science, but it also communicates the science better, as opposed to using the clear water, for example. I am also convinced that for you, all of us, for making the representation, it clarifies the science in our own minds. How do we communicate the idea that this is what we were talking about, entanglement? What's the best way that truly communicates something impossible to communicate? But we run a series of workshops, and I'd love for you all to consider doing this on your campus. I've created this visualization of very complicated pathways, and after lots and lots of talking and wringing his hand, he went along with simplifying these pathways, editing down what it is that we really don't need. That's one of the problems that I run into. All of you guys want to show everything, and in the end, we don't want to look at it. I'm still thinking that I would still do more, but it really is about clarifying the science in his own mind, and that's the point of, that's why I believe it should be part of your education. I also think that making representation should be collaborative. You shouldn't just be sitting at your desk with using your software, which is probably informing your representations, but that's another conversation. But it should be speaking with each other. And what we do, as I mentioned, it was we run a series of workshops where we show each other our graphics. And oftentimes we walk away with very, very different ideas. The best workshop is to make it interdisciplinary and get ideas from other disciplines, because there are universal problems involved with visualizing ideas. The problem is that you just assume that when you're imagining how to visualize something, or in this case, dancing something, you think that everybody is seeing what you want them to see. And it is not the case. It's sort of in a way, it's a Rorschach test by looking at something that you haven't seen before. I showed this many years ago, and I deleted the subtitle, and we don't have time here, but take a look at this. And what do you think you are seeing this data visualization of? I'm going to suggest to you that you are putting it into your discipline and you're seeing something that you think it is because that's how you're thinking. Well, just so to tell you what you're looking at the subsurface structure below a sunspot using a particular analysis. Maybe some of you saw some oceanographic images, but the idea behind this is that we should in fact talk to each other and come up with universal strategies. One of the biggest issues, by the way, is that every discipline has its own color palette. Astronomy is very different, for example, from looking at oceanographic image making. So the talking together is an incredibly valuable idea, which we've been running for quite a while. And, you know, I'm sorry to be so crude, but making the right visual helps with your funding. Getting the advisor on the funding agency who doesn't know the first thing about your work, you've got to get them to get it. And so, believe me, this is all of Langer's work. Bob does not need me to bring attention to his work, but this is an image I made of his work that it was nuts. It got attention all over the place. Yes, the work was important, but the visual was spot on, a simple visual about how this device can supposedly end drug injections. It is a means of selling your good science. I'm not embarrassed to say that I help sell science as long as it's good science. And in the end, this is my thing. Ultimately, making the right representation makes science accessible to the public. And yes, I'm getting a little silly here, but I feel very strongly that we cannot just talk to each other. We have to engage the public. And I feel also strongly that one way of doing that is through smart, communicative images of all sorts. I do mostly photography, although now I'm getting very deeply into graphics. I have a class online. Honestly, I think it's very good. It's called Open Courseware at MIT. It's a series of tutorials. I'm not running the class anymore, but you can see what it is that mostly photographing science is all about. For example, I show how you can use a scanner. It's crazy. I consider it cheating because it's so easy, but you can put on some beautiful devices, materials that you've made. This is a simple scanned image. Here, the scientist handed me all these materials, said, can we try to get a cover? And I am not kidding. This image took all of 2 minutes. It's a scanned image. This is a picture from the scanner, and I did, in fact, add a background, but you can get extraordinary detail from a scanner. These are devices. These are 1 centimeter across devices that we'll use to inject vaccines, for example. Here is a euplectella. It's a sea animal. It's a skeleton. This is put on the scanner. It's a very large file. I am zooming into the image. I'm not making another image. It's zooming into a 340 meg file. You could see detail of 50 microns on the scanner. It's crazy and wonderful, and you should consider it if you're making things, even 3-dimensional things. I talk about using your phone. In fact, this nature cover I made with my phone. Now, I do talk about the reason why it worked is because I composed it exactly for the cover, so I didn't have to zoom in. At that point, the file size of phones are not quite up there the way we want them, although it is getting there. Here's another image that I made that I'm using for a children's book. What do you think this is? It's a guessing game. But what you're seeing is I was sauteing peppers, colored peppers, and you're seeing the condensation on the glass cover, and all up and optically things are going on. So that's what you're seeing, all taken with the phone. But here I'm making the point of the file size. This is an image of a petri dish with 4 conditions where E. coli are growing in the 4 conditions. This was taken with my phone, and this image was taken on a scanner. And when you go into their detail, you see that the resolution is not there, but it will be. It is getting better and better. And it's really quite remarkable what you could do with your phone. I've changed my mind about it. And so it's something we could talk about again offline. But obviously photography is all about light. Here I'm showing one device taken with all kinds of different lighting. I have a chart that goes with it. This is a fishing reel, believe it or not. And I put it in a garbage can. And look what happens when I simply add just an additional light. The whole image changes. There's a major chapter in my book. Later on, I'll talk about that tells all about that. Here, it's quite an old picture, but still it makes the point that this PDMS material has a grating on it, and the grating refracts the light, the white light, but you can't see the refraction until I put a shadow in there. I held a white card over the light source so it could look, you could see the shadow, which then details the various colors of the white light. I talk about backgrounds. I love bringing in designs done by hand. I'd love us to get back to handwriting and drawing, and that's another conversation, but using backgrounds as a storytelling device. One of the things I feel very strongly about discussing is how far can we go when enhancing an image, and that's a long conversation. But for example, here's an example of yeast colonies that were growing in a petri dish, Jerry Fink's lab, and I was mind blown how glorious this morphology of the colony was. So I decided to delete the background because I believed it's in the way of your seeing the data. I am not deleting any data. Jerry thought I was deleting the data. The data for him was suggesting the size of the yeast colony because people understand how large a petri dish. We went back and forth on it, but in the end, it got the cover of Science, which he was happy about. But in the end, I want you to look at this amazing thing that's going on. The data for me in this image is the morphology. And that to me is what responds to the question, how far should I go? But always, when I do anything to an image, I tell you that I do so. For example, this is Proteus colonies that I made an image of. They also are talking to each other, telling each other where to grow, which is amazing. But you see the agar was cracking. And so I digitally deleted the agar, the cracks that were being in the way of getting you to see what I wanted you to see. However, and by the way, I always indicate that I've done that. But the question is, those pieces that I deleted might in fact have some information. By deleting what I consider outliers, we're deleting what we see. And I ask you, are some of these outliers more important than others? Who's deciding on what it is that we're deleting? If we delete the outliers, are we deleting important information? And in the end, can the machine in machine learning determine what is important information? I'm raising this issue in photography, but also, of course, I'm raising the issue in data information as well. It's something to always keep in mind, the honesty that we have to, the integrity that we have to include. We look at case studies. This is I started with this ugly picture of plexiglass because I had an idea. I laid a graphical element of graphene on top. I went back and forth with Kelly at Nature about how maybe the cover should be. And then eventually this was made with pieces of pictures that I have accumulated. This is something that I love doing. This is actually a metaphor or for something called remote epitaxy. And I worked with Nature on that. But in the end, it is an abstraction. It is a representation of something that we really cannot see. The same thing with this. This is another metaphor for a cover. Here you're seeing a syringe that has a drop of water in it. It's an image that I made for a book called No Small Matter. By the way, if you might be interested, that you see the water drop is acting as a lens that is getting in focus the background, which is out of focus, which of course is what I wanted it to be. But in the end, what we wanted to do was create some sort of visual to express what's going on scientifically. So I took the drop, I started elongating it. I put a syringe on a scanner. I took the syringe, inserted it into the drop. I took some of the images that the researchers were making. These are pancreatic cells that are fluorescing. And that's the final image with a little stretching and all kinds of stuff, creating what is a metaphor for what they're doing is alginating the cells so they are protected, that the macrophages are not going to attack the cells. And this is a metaphor for what it is what's going on. It's fun. I mean, I'm actually having a lot of fun doing this kind of stuff. Right now, I'm unabashedly, disgustingly pushing this new book that it's a handbook, actually. It's quite small. It's only $20. And it's part of a series that we're calling the Visual Elements, handbooks for communicating science and engineering. That's coming out in November. You can pre-order it. The next element is called design, which is what I'll just touch on very briefly. It's going to be a small hand. Each of them are doable. That's the point of the other book I made was too big. It was too cumbersome. This is going to be easy. And so I want in that book, I'm going to talk about how design is all around us. For example, when I'm on the subway and I'm going to outbound to Alewife, this is my T stop at Kendall, which is MIT. And if we had some time, I would ask you what is it that the designer decided to do about naming all the T stops? And the answer is because I'm at Kendall going to Alewife, I don't need to know the names of the design of the stops before. So this was a design decision. This is a decision on what to leave out. And that is the biggest challenge that I have with you guys. You want to say everything because you've done the work and you want to put it in the figure. But I am telling you, it ain't working. It's just too busy. This is the conversation that we have in the workshops. So in this new book, this is one of the copyrighted problems that I'm showing now. Jonathan is an extraordinary illustrator at the New York Times. And so what we've done in this new book is a case study of how he started going from one step to another to show COVID infection. And here's another very talented Martin and Fernanda who do really pretty remarkable data visualizations. And we take you through their visualization case study and from here to there. And I'm going to get László to get involved, but that's another conversation. You wait and see. And so in that book on design, there's a major chapter called Figuring the Figures. This is where you put too much information in. Here's an example of a researcher who these are two explosions. he wanted us to, of data, he wanted us to make the comparison between the outlined area on top and the outlined area on the bottom. And what I'm suggesting is, if you want us to see that, get rid of the color that is not necessary. Help us see what you want us to see. The same thing with this. This is out of Pecco's class. It's a wonderful class on sports mechanics. And here the data are all these X's. And yet, because it's a soccer field, they decided to make it like an ordinary soccer field. But I suggest, look, if you want us to see those X's, don't color it green. Get us into a palette that gets us to look better at where you want us to look. As what I said before, it is that you know too much. You know to where to look, and you're assuming that we're going to see it. That is not necessarily the case. And finally, the third book I'm working on right now is called Abstraction. I'm having a blast collecting other people's works in metaphors. And this is what I meant, Laszlo, about spending a lot of money for permission. This is what I didn't anticipate, but I'm having so much fun. Maybe this will be the cover, I'm not sure, but this is an abstraction, isn't it? This is trying to show an alien who we are, sorry, and what it is that we do. I'm not sure it works, but that is the idea of getting you to think of representing ideas and concepts. This, I think, is a successful metaphor for showing what is going on, the content of the universe. It's not precise, but it sure shows that dark matter and dark energy are there much more than anything else. Here, this one is out of a class that we ran. I've collected 3,000 images from students on their metaphors of how to represent concepts that we're learning in their classes. This idea was about Brownian motion. It's very clever, but it's always falling. All metaphors fall apart. In this example, number one, the particles are all the same size, which is not the case in Brownian motion. And more important is the environment plays a very important role in Brownian motion, and we're not seeing that in the metaphor. But you should see some of these drawings. They were absolutely fantastic. I'm also showing non-scientific images that I think are just mind-blowing. I think this one at the cover of the New Yorker, when the immigration policies were coming out, that is not what we're all about in our country. I thought this was extraordinarily powerful. And this one as well, more recent, about, again, most of these metaphors, you need text to go with it, true, but it's you know what it's about. So I'd love to hear from you. I hope you got something out of this. I certainly have gotten something out of Laszlo talk, and I'm happy to answer any questions.
Feliz, you're not a photographer, you're not a designer. I think you're a magician. You're misrepresenting yourself. Just be really
thank you. You have to know, I have a blast. The dirty little secret is that I am learning as I'm doing this. That's why I want all of you to consider doing this. It's fun, and we're constantly learning. And by the way, MIT is not a bad place to be. By the way.
Okay, so we have a question. Christina, please unmute yourself.
Yes, thank you very much. I hope you can hear me.
Yes.
Thank you so much for this very inspiring, enthusiastic, and really fascinating presentation. I have a question because I come from the other side. I work in the humanities. I'm a historian, and I work a lot with arts. So I'm very familiar with concepts and ideas that I think have something to offer to persons in the experimental sciences and life sciences. But I find it difficult sometimes to break the ice, to start the conversation, to invite the synergies. So in your experience, what could be this meeting point for persons who are in contact with a lot of concepts and ideas coming from the humanities and the arts in order to find a collaboration with STEM and hard sciences? Thank you.
Yeah, it's a great question. And I'll tell you, can you imagine how it was when I came to campus in 1994? For me, a position opened up, and that's how I got to campus. How I would start introducing myself to these people. I mean, they thought I was nuts. You know, they were very cordial and all. The key is, and this is not what you will probably want to hear, but you have to show them that you can do better than they can. This is what worked for me. I had the images that I created before, and it was a before and after. That's what I show a lot in the books, befores and afters. It's one thing to be intellectually engaged, which you could say that would be interesting for you. You have to, people are very busy. You have to show them what you can offer, even if it's small. Getting, you know, if you could connect it to their work, not just at this large issue of, I really think humanities have a lot to offer you. It's not going to cut it. If you go to one person, see what they do in their research lab, and raise a particular question, or even better, show them where their visual is lousy. Of course, you have to be careful about how you say that. But I'm being very frank with you. It's not enough to just want it. You have to get them to think that they could get something out of it. This is what life is about.
Thank you so much. Thank you.
Any other questions? Yeah, Katalin?
I have seen that you have some courses related to teaching some of these.
Yeah, you go to OpenCourseWare at MIT and look for Felicfabric. Honestly, they're not courses per se anymore, but there are 42 tutorials. Really, they're very well done. It's just voiceover. You don't see me. I had a wonderful production team when I had money, and they're good. So I'd like to encourage you to go there, and of course to get the book.
Okay, thanks.
Yeah, OpenCourseWare it's called. Don't go to edX because you have to pay for that. You don't have to pay for this.
Oh, that's great to know.
Yeah,
Yes, because it's really amazing, and I think we all could learn a lot from.
Well, it's fun, and it's fun too, by the way.
And I certainly agree with you that we should communicate with the public. I mean, at least as scientists, we are using their money to work on our curiosities and to explore what's out there, and we have to communicate.
It's critical, especially these days when so many lies, I'm going to say right out, lies are given. And I think it's through visualizations and images. Well, you know, I don't use the word visualization because I think László and I write that mostly visualization is mostly about data. Is that fair? I don't want to say photographs or visualizations, because that would just muck up the waters, although they are in a way. But I like to make that distinction. But I am convinced that pictures engage people, period. Yeah, good, I'm glad you agree.
Yes, I do.
I can't find anywhere my hand to raise. I'm sorry, I still, but so I'm going to raise my physical hand.
Yeah.
And I'm wondering, Felice, when do you come into the picture in these journeys? Like, how does a collaboration look with the different people? Or can you give us one or two examples?
Yeah. So absolutely. So right now I'm formally supported by 3 departments. And those departments know that I'm here for them. And they also know that they can come to me when their paper is accepted. I'm not going to work on something that is not going to work. So once the paper is accepted, like I'm working to this afternoon, I have a Zoom with people about a cover submission. So they come to me, and then we sit down and we go through, they explain to me what it is the science is. They usually have some sort of diagram, and then we brainstorm, and I come up with some ideas, mostly photographic, and if it needs to be illustrated, then I bring other people into the conversation. But that's the way it works. They know I'm there, and frankly, I get requests from people outside of those departments too, and I just do it because it's the right thing to do. So that's a really important filter, that they really can't come to me unless it's been accepted. But we'd have these workshops. That's a totally separate thing, where the researchers will give me. We run 12. It's a 12 people workshop. 12-person workshop. They send me their draft figures, and as a group we meet and go through the figures. They have been very, very good, if I do say so. I've kind of whittled it down to 12. That works. It doesn't work for more than that. And that's another thing. It's the workshops that work. Yeah.
That makes lots of sense. That's a little different from what we do in the lab, right? Because we start engaging in a much earlier stage, and the designers are also involved in kind of doing the final figures for the paper without knowing whether that would be in a high-profile journal or a lower profile. Right?
Interesting.
Obviously, often by the time we get accepted in a journal that does have a cover, we already have a set of visuals that we can actually suggest for the cover.
Interesting. Yeah.
In the meantime, thank you very much, Brian.
But there's another question.
In the
no. Ben, no.
I don't think so. But
Okay.
Brian shared the course link through the messaging.
Good. Excellent.
You can see it on the chat box. And I hope we had more time, but we ran out of our time. I would like to thank you very much for captivating visuals and enlightening perspectives. You've been great, the two of you. And thank you very much, all the attendees, for joining us today in this event. And I would like to just remind you to save the date for the next webinar for our Arts and Science series on September 25th at 2 to 3 Central European summertime. This will be a panel discussion with Miriam Sturde, University of St. Andrews, Peter Weingart, University of Bielefeld, and Joseph Lindley, Imagination Lancaster, about ethical and social challenges surrounding visualization and communication practices in science. Thank you, and see you hopefully in the next event.
Thank you.
Take good care.
Laszlo, I'm writing to you.
Wonderful.